Today we will discuss the topic, the relation between electric field intensity and electric potential, the equation which connects E vector and V. We have studied so many equations for electric field intensity as well as yesterday for electric potential. Electric field intensity was given by the equation F equals QE. From there, E equals F by Q. The electric potential was given by the equation W by Q naught. These two equations can be connected each other by using a relation. For that purpose, I am drawing here a uniform electric field line. You know well that a uniform electric field intensity line, or simply an electric field line, will originate from a plus Q charge and it will terminate at a negative charge. So a uniform electric field line will originate from a plus Q charge and that line is going and it will terminate at a minus Q negative charge. Just like we did yesterday, we will consider 2 points A and B in this uniform electric field line. We are considering 2 points A and B and they are lying closer to each other, A and B, in this uniform electric field intensity line. Let a test charge Q naught be placed at the point B. So what should be the next process? This Q naught test charge should be gone to the point A. So look at the electric field intensity direction. It is from left to right. But I have to displace the test charge Q naught from the point B to A. Against the electric field, against the force of repulsion, I have to apply the force. I have to do a work to move the body, to move the test charge from the point B to A. So I have to perform a work. The distance between points A and B can be termed as dr. It's a small displacement. So I have to apply the force through the displacement dr. So I will get the necessary work. You can see that here in this picture, the electric field line is originating from a plus Q charge. So it is the direction is from left to right. Now I have placed a test charge Q at the point B also. So definitely on the test charge Q, an electrostatic force will happen. That is in that direction from left to right because they are repelling each other. What is the magnitude of that force? F equals QE. But I need to move the test charge from right to left. That is from B to A. Against the electrostatic force of repulsion. The Q always tends to move from B to infinity, but I have to move the body from test charge from B to A. So work should be against the electrostatic force of repulsion. Last days we studied about electric potential difference. What is called electric potential difference? Electric potential difference is the work done in bringing a test charge Q from the point B to the point A. So here I will write the electric potential difference as VA minus VB. VA minus VB will be equal to work done divided by the value of test charge. VA minus VB will be equal to W upon Q. VA minus VB is nothing but it's a change in potential difference, right? So instead of VA minus VB, I can write like this. dV. D means a change. So dV will be equal to W upon Q. dV will be equal to work divided by test charge. Now the next step is, instead of work, we have to apply the equation for work. What is the equation for work? Force into displacement. dV equals force into displacement divided by charge, test charge Q, which will be equal to, what is the value of electrostatic force? Relation between electrostatic force and electric field intensity. It's already written on top. F equals QE. So instead of F, we are writing QE dot, what is the displacement from B to A? It is dr. So QE into dr by Q. But you see here, there should be a negative sign, correct? Because force is happening from left to right. But you see, displacement should be done from B to A. Thus the negative sign shows here that the direction of intensity is opposite to the direction of the displacement. Intensity direction is from left to right, but the displacement dr direction is from right to left, from B to A. So after all these theories, I am making the enough substitutions here. So dV will be equal to force into displacement by test charge, which will be equal to minus QE into dr divided by Q. Q and Q will be definitely cancelled each other. The values left are QV equals minus E into dr. dV equals minus E into dr. Here you know well that V is nothing but it is electric potential. And what is E? It is electric field intensity. Already we got the relation, no? The question itself is, what is the relation between electric field intensity and electric potential? The relation between E and V. We already got an equation. dV, change in electric potential, will be equal to the minus gradient of E into dr. I will rearrange this equation like this. E will be equal to, that is electric field intensity will be equal to minus dV by dr. That will be the required expression that connects E and V. Electric field intensity E will be equal to minus dV by dr. This is the required expression, and the quantity dV by dr is called potential gradient. That's a very important term. The quantity dV by dr is called potential gradient. From this equation, it is clear that the negative of the rate of change of potential with the position will be equal to the intensity of electric field. That is E equals minus dV by dr. What is that expression? The negative of the rate of change of potential will be equal to the intensity of electric field. Write this derivation question also in your notebook and submit it to me as an assignment. Thank you, students.